Hello everyone, welcome back to our channel. In our previous video, we solved a similar type of question where we needed to find the rate and the principal when compound amount was given. In this one, we'll again be trying to find the rate and sum when compound interest is given. So we have our question, the compound interest on a certain sum at a rate of yearly compound interest in 1 year and 2 years are respectively 1800 and 3816. And then we need to find the rate of interest and sum. So first, let's just write the given things. So we have our solution. Again, we have two cases in this question as well. So we have our case 1. In our case 1, our compound interest is Rs 1800, right? So Rs 1800. And our time period for this compound interest is just 1 year. Similarly, for our second case, we have our compound interest as Rs 3816 and our time period is 2 years. And what we need to find is the principal amount and the rate of interest. Now, we're going to make two equations from these two cases. So from our first case, we have compound interest 1 is equal to the formula of compound interest is P bracket, again bracket 1 plus R divided by 100, bracket close, power T minus 1, bracket close. So this is our T1. Now when we put the value of compound interest 1, we have this as 1800 equals to, we have our P bracket, another bracket 1 plus R divided by 100, bracket close. Our T1 is just 1 year, so I'm just going to write 1 over here minus 1, bracket close. So this is going to be our first equation. Similarly, for our second equation, again we have our CI2 is equal to P bracket, another bracket 1 plus R divided by 100 whole power T 2 minus 1. And we have our compound interest 2 as 3816 is equal to, again we have our P big bracket, small bracket 1 plus R divided by 100, bracket close. Our T2 is 2 years minus 1. So this is going to be our second equation. Now again, what we're going to do is we are going to divide these two equations, okay? So I'm going to divide equation 2 by equation 1, just to put the bigger number in the upper part of the fraction and the smaller number in the lower part of the fraction. So dividing equation 2 by equation 1, we get 3816 divided by 1800 is equal to, we have our P big bracket, small bracket 1 plus R divided by 100 whole square minus 1 divided by, again we have P big bracket, small bracket 1 plus R divided by 100, bracket close. Here we had 1, we can just ignore that, minus 1. Now we can easily cancel this P and that P. And when we divide 3816 by 1800, we get 2.12 is equal to, over here, we are going to use the formula of A square minus B square. So this 1 plus R by 100 whole square is going to be our A square minus this 1 square is going to be our B square. So when we have A square minus B square, we can put the formula A plus B and A minus B. And that's what I'm going to do here. So we have our A plus B as 1 plus R divided by 100, bracket close, plus B is going to be 1. And our A minus B is going to be, again, 1 plus R divided by 100. This is our A minus our B is going to be 1. Again, bracket close, divided by, over here in our denominator, we have bracket 1 plus R divided by 100, bracket close, minus 1. Now again, we can cut this entire thing and this entire thing, okay, because they are same. And now what we have is 2.12 is equal to 1 plus r divided by 100 plus 1. Okay, I'm also removing those brackets. So over here we still have our 2.12. When you add this 1 and 1, it's going to be 2. When we move that 2 to the left side, it's going to be minus 2 is equal to, we have r divided by 100. So when we subtract that, we get 0.12. And when we move that 100 to the left side, it's going to be multiplied by 100 is equal to r. And this is going to be 12 equals to r. And therefore, our rate of compound interest is going to be 12%. And in this way, we have found our rate of compound interest. Now, for the principal, what we are going to do is we are going to substitute this value of r in one of our equations. So I'll be substituting the value of r in our first equation because this equation seems a little bit easier than our second equation. So putting the value of r in our first equation, this is our first equation, right? I just copied it down here. What we're going to get is we still have our 1800 here equals to, we have our p bracket, we have our 1 plus our r is 12, so 12 divided by 100. Okay, I can just remove that bracket because it's just power 1, and we have our minus 1 over here. You can just cut this plus 1 and minus 1, and we have 1800 is equal to p times 12 divided by 100. Now when that 12 by 100 comes to our left side, it's going to be 1800 times 100 by 12 is equal to, we have our p here. And when you multiply this and divide it by 12 in your calculator, you are going to get 15,000. And therefore, our principal amount or the sum is Rs 15,000. So what's different in this question than our question of compound amount is in this particular question, we have to use the formula of a square minus b square over here, okay? Whereas in our question of compound amount, we just use the law of indices because there was no minus 1 in that question. In the case of compound interest, we will have minus 1, and in those cases, you have to use the formula of a square minus b square to solve the question, okay? Then you can just easily cut things and then find the value of r, and then by substituting that value of r in any of the equations, you get the principal. So if you enjoyed our video, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.